So what we're going to do now is we're going to do operations with functions, which is not much different than what we've done with polynomials or anything else. So the first I'm going to start off with addition and subtraction, which is simply adding like terms. So if you have a function, it's written like this, you're just going to separate those functions and write each part and then add like terms. So if we look at our first example here, I have a function x squared minus 4 and a function 2x plus 1. And this is the notation f plus g. So I want to add these two functions. So if I write my first function, which is f, and I'm going to add it to the second function, all I have to do is add like terms. So I don't have any other x squared, so x squared is part of my answer. The negative 4 will go with the 1, and we have our 2x. So putting things in order, we have a 2x minus 3. So only two things that can be actually added are the negative 4 and the 1, because they're like terms. And so we end up with this for our adding the two functions together. Now let's look at our next one where we're doing subtraction. Well, I'm going to take the same two functions, x squared minus 4, but I'm going to subtract. But here's the key. I have to put this in parentheses of what I'm subtracting. And by doing that, I have to make everything change to its opposite sign. So if I have x squared minus 4, this is going to be a minus 2x, and this is going to be a minus 1. And now I still add like terms. My x squared is still its only variable, my minus 2x is, and my negative 4 and negative 1 now become a minus 5. So these functions look very similar, but they're technically the same thing we've been doing. Subtraction is the most difficult because we have to make sure we subtract by changing the sign. And so here is our answer for subtraction. So now we're going to multiply and divide functions. So let's start off with our multiplication. So I'm going to take this function and I'm going to multiply it to this function. That's what this notation means. So I'm going to go ahead and write in multiplication form x squared plus 7x plus 12. There's my first function. Now I'm going to have parentheses 3x minus 4. So what we're going to do is basically we're going to distribute. I'm going to multiply this first time times that. So I'm going to write 3x cubed. And I'm going to go x squared times the minus 4, which would be a minus 4x squared. Now that I've multiplied both of those, I'm going to multiply this 7x times 3x. But now what I'm going to do is I'm going to line up the same letters. So that's going to give me 21x squared. And then 7x times minus 4 is going to be a minus 28x. And then I'm going to go to my 12. And I'm going to do it another color. 12 times 3x is 36x. And 12 times negative 4 is a minus 48. So all I did was line up all the like terms after I'd done multiplying. So I can just add like terms. So 3x squared, or cubed, I mean. If I add these two, I'm going to get 17x squared. And if I add that, I'm going to get 12, I think it's 12, not 12, add that correctly, that would be 8x, and then minus 48 to nothing is a minus 48. So addition is simple, or multiplication is simply distributing, and then after distributing, adding the like terms. So now let's look at division. Division is like a fraction. So I'm going to take my f function because it's on top. Then I'm going to go x squared plus 7x plus 12. I'm going to put it over the g function, which is 3x minus 4. So now we have to look at this problem and see what can we divide out. To do that, we need to factor if it can be. So can this be factored on top? Which it can. It's x plus 3, x plus 4. That's the top part. Bottom part can't be factored, so it's just 3x minus 4. If either one of these were alike, exactly the same, then I would cancel them out, and that would be left my answer. But nothing is, so this ends up being our answer.